Oh my gosh, poor little thing. Had a rough night. So the mean is 1,015, goes right in the middle. And I want to know between 930 and 1,050. The scale doesn't have to be good. You just have to put them relatively in the right place. So a quick visual. That's the area I'm looking for. So I make each one of these. I know this middle dude's going to be 0. I need to know what these guys become. So 930, how far from the mean is it in terms of standard deviation? What do you guys get for that one? It was negative 0.62, is that right? So that's negative 0.62 z-score. What about 1,050? Exact same formula. Okay, Jeff. And then what does that come out to? Say again? 0.23? 0.26 then, right?
Yes.
That's neat. I can't claim the symmetry was me. So that's 0.26. So when I look up 0.26, it's going to be too much shit. So then I got to subtract whatever that is. So what do you guys get for 0.26? Well, hopefully you got this. There's a lot of 6s and 2s in this round. Neat. 6026. So that's that area, and that's too much. I want to stop here, so I got to subtract whatever this is. And if I look up negative 0.62, negative 0.6, yeah, 2, 0.2676. Sorry, I'm weird. I get all excited about neat number things happening. So then if I do 0.6026, that's too much. If I subtract off 2676, I'll end up with exactly the area I want. And then what do you get when you subtract those things? Was it 335?
Yep.
Or 33.5% chance. So how do I really interpret this? 33.5% of people living in this area pay between $930 and $1,050 a month in rent. Woo! You guys with me? No? Sort of. Physically in the same room? Okay. Part B is that backwards problem. It starts with the percentage, which is normally where we end. So I do everything in reverse. So I know I want it to be the 15th percentile, so where is it going to be? It's going to be up here, down there.
Down there.
Yeah, down, because it's only supposed to have 15% below it. So this is what I was saying before. Percentages look like z-scores. They're so evil. So be nice to yourself. The minute you know it's a percentage, you put it up top. If it's a z-score, you put it underneath. So that the visual reminds you what the shit's going on. So now I need to figure out the z-score for this, and then I can work backwards to figure out the x-score for that. So how do I find the z-score for this? What do I do? Kind of makes sense. I want to use the z-score chart, but I'm going to use it in reverse now. I don't know what the z-score is, but I know the area is 0.15. I know it's going to be a negative z-score. You guys, these aren't things you got to memorize. These are facts that will help you. I know it's below the mean. Let me look at the negative side. 0.15. What's the closest you can get to 0.15? Is it Columbus? I think it is. Let's see what I mean, maybe. That, I think, is the closest you can get to 0.15. 1492. Right. Came over, killed all the Indians. Negative 1.04 is what it looks like. Are you guys, is everybody with me? So that would be a negative. If I go down a little more than a step, then I got about 15% below that position. That's what we just figured out. Now I want to know what the rent is. It's obviously not negative $1.04. I'm not going to get paid $1.04 to live there. That'd be freaking awesome. Shit. Too bad for us. So I got to make it back into an actual rent. So I take the mean and I go down 1.04 standard deviations. Now, to be honest, if you think back to 2-7 homework, you guys were doing this before you knew the formula for this. If you did the 2-7 homework. Because it just makes sense with what z-scores mean. This many of these below that. So what do you guys get for that? I don't know. 872.61. Sure, sounds about right. 872.61. I like it. Sweet. Sounds like a good price to pay for rent. My first place, I paid $326 a month. It was in the basement with the hot water pipe running through it, but $326 a month. Yeah, please, thank you. Sorry, not anymore. Find the probability that a 3-bedroom flat would cost more than 16. So you immediately draw the picture, put the mean in the middle. There's $1,600. Weigh the shit up there. I want to know the area above that thing. So I already know the answer should probably be kind of small. And this is where a lot of you guys kind of freaked out. I don't blame you too much. So my score, I'm interested in minus the mean divided by the standard deviation, which is still 136.91. And you get, I think, 4.27. Mm-hmm. Now, I agree that at 3.5, there is this much below. But the minute you get to 4, 4.2, 4.27, there's even more below, which means there's even less above. So I would say there's approximately 100% here, so there's approximately 0% there. You, if you wanted to, do what the book says and get your 0.0001 and be fine with that, because that's what the chart says. You guys kind of, but here, the minute I get beyond 3.5, right, I'm way up at 3.5. So it's like the height. Who is 3.5 steps above the average height? Who's above that? Like nobody. Forget about it. Ain't nobody. It's like approximately 0% of people are out there. You guys semi with me a little bit? That's one thing about this chart I don't like, is it makes it seem like it's going to forever be the same, but you know if you follow the picture, it's getting smaller and smaller and smaller. Less and less and less shit out there. You guys all right? So you can do one or the other. If you're off the chart, you could do the 0.999 or the 0.001 thing, or you could do the approximately 100, approximately 0%. Okay. Then we come to San Diego. Reality hits. By the way, these are in US dollars, right? Not in New Zealand dollars. It's different.
Kiwi bucks?
Huh?
Kiwi bucks?
Kiwi bucks. I don't know if I'm going to say that because I'm not sure. This is called New Zealand dollars, to be honest. So the mean rent here, to be honest, somebody asked me about this. I kind of averaged sort of several that I found. There's different ways to calculate the average rent because it's like, do you include rent control? Do you include all these other situations or not? So I just averaged all the ones I found. Kind of made this shit up, but oh well. That's why I didn't give myself a link. So find the probably that a 3-bedroom apartment here would cost between these two. So this is very similar to what we did earlier, but now the middle is going to be $2,884, and I want to know between $2,400 and $3,000. So again, I just make both of those into a z-score, look up the area, subtract those to get the area between. So I know, when you're taking a course like this, you get into the flow of the technical nuts and bolts number shit, but you forget that this all has immediate physical meaning, right? This will be the percentage of people that pay between those rents. So what do you guys, for the z-score for 2,400, I know it's going to be negative. What do you guys get for that? Negative 1 point. So negative 1.40. That sounds right. negative 1.40. What about for 3,000? What do you guys get? 0.33? Neato. And then if you look up those areas, so the area below 0.33, what do you guys get? 6,293? And the area below negative 1.4? 0808. 0808. And then if you subtract those two, you get the area in the middle. Please let that make complete physical sense. Please. What do you guys get when you subtract those two? Whoa, make numbers, Jeff. Gonna make me do it? 5485. So about 55%. I already admitted I sort of made these numbers up, but oh well. It's really just to get the technique down. But if those numbers are true, then about 55% of people living in a 3-bedroom apartment pay between those amounts for that apartment. All right. Find the rents below 1,800. Where is it? 2,884. There's 1,800. That would be, well, I was going to say that would be great, but you might be living in a sketchy part of town for that. I don't know. So make that into a z-score. Where'd it go? 346.64. What do you guys get for that z-score? Sorry?
Negative 3.1. Negative 3.1.
Negative 3.10? 3.13?
Yeah.
Sounds good. And then you look up negative 3.13, and I get 009. And that's the answer, because I just wanted below that. It's awesome when the question is below, because the chart tells you below. Yay. And then this dude, the 90% middle, that's a lot like that 40% one we did earlier. So if you draw it, oh my gosh, there's 90% between. So what's below this z-score right here? 5%. So if you look up 0.05, you should get into a situation, this little asterisk dude we saw before, and that comes out to the 1.645 that we've seen before. You guys all right with me? All right with that problem? No, the problem's okay. You suck. So where'd it go? 1.645. So what's this going to be? Positive 1.645. And then you just convert each of those. So for example, if I start at the mean and I go down 1.645 standard deviations, I'll get the bottom rent. What do you guys get for that? All right, it's a big secret. You're not going to tell me. So I get that, 2313.78. And what I like to do real quick, see how that's in there? Second enter. Crap, Jeff, make that a plus. Yay, bam! So I get 3454.22. So watch how I can write this. So it'll be between 2313.78 and 3454.22. What form is that in? Super Saiyan? No. What form is that in? From algebra.
Excellent.
No, careful. It's not a point. It's an interval. It's an interval notation. So how confident are you that any given 3-bedroom rent in San Diego is in there? Let's see if you guys can. This is cool. How confident would you be? Somebody is living in a 3-bedroom flat. How confident are you that they're paying somewhere between these two things?
90% confidence.
Yes, 90% confident. Does that make sense? Why are you 90% confident? Because 90% of everybody pays between those two. What's the probability that they don't pay in there? 10%. 10% chance you're wrong means you're 90% confident. So I would call that interval a 90% confidence interval. This is going to be chapter 7, by the way. It's going to be all about these confidence intervals. I'm sorry, chapter 8. I'm getting a little ahead of myself. All right, maybe. Any questions on that whole thing? So, before I let you out, I want to kind of give you a preview of where we're headed. I'll turn you around. Just want to lay some groundwork for next time. This is going to be very strange, and I don't care. That sounds so thoughtful, Jeff. All right. No, what I mean is, this is there's part of this that makes complete sense, but then the actual way things change, it's a little too much math to do here. We just got to, let's just do it, Jeff, and see if it makes sense. So I go to a parallel universe, just because I can, and I want to, right? And I got the right portal gun. So, in this parallel universe, Florida, there we go. The ages in Florida are distributed like this. All right, so what this means is, let's say 0 to 100. Nobody makes it up to 100, too bad. Let's say the middle looks to be 50. We'll make it 45 just because. So this is kind of like who lives in Florida? If you listen to all those stories. Yeah, retirees, but also young people, right? Think about Florida, there's a ton of young people, Miami, whatever. And you see a lot of old people doing shuffleboard, enjoying the heat, right? You guys with me? Okay, if you've never been to Florida, don't go. I lived there for a while. Now, this is kind of neat. This is a sample size of 1. How would I create this picture besides just making it up? This is an alternate universe, so this is true in the alternate universe. Prove me wrong. How would I go around and actually make this picture? How did somebody make this picture? I said, let's pretend this is Florida. I said, how old are you? And you told me, and I plotted your age. How old are you? I'm 2 months. Okay. Speaking already, damn. How old are you? I'm 89. Okay. Right, you guys with me? And I kept going. No, right? So it looks like most people were this age, whatever that age, and then maybe this is about the same, I think. You guys kind of with me? That's how that picture was created. I'm making a big deal out of this for some reason. What would be the most likely thing to happen if instead of asking one person at a time and then plotting it, what if I asked 10 people and plotted their average age? So if I ask 10 people, hey, what are your ages? And then I did the average of those. And I'm looking at their IDs to make sure they're not lying to me. Well, I'm 29. I don't think so. You guys with me so far? Is it likely that I would get a bunch of, like 7-month-olds? Just randomly. If I randomly pick 10 people, am I going to get a bunch of 7-month-olds? No. Am I going to get a bunch of people right here? What's the most likely thing to happen if I randomly select 10 people? You could do this. Yes. Because what's the expected value going to be? The mean. Let me put mu here. So from 10 people, the most likely thing is I'll get a mixture of younger and older, right? Will I always get that? No. But if you had to guess, if I said I just took a random group of 10 people from here, and your guess would have to be a mixture. That's what makes sense. Nobody from these two groups should be more likely than the other one, so forth. You guys sort of with me? So if I draw this new picture, now stay with me, this is huge. What I'm drawing now is I'm not plotting individual ages, I'm plotting the average of 10 ages, and then I put a point. So where's the biggest peak going to be? Let me put it down here. Where's the biggest peak going to be? Yeah. Because that's going to be the most likely thing. Now the next most likely thing would be a bunch of people around the individual peaks. So maybe it would look like something like this here. Oh God, there's nobody up there, Jeff. They all died in 400. It's like some weird take on Logan's Run.
Is it like a knock at your door?
See some 99 and an 11-month-old start running. Oh, you're not going to get me. You never seen Logan's Run? I don't know what's Jeff, stop it. You have no idea what it's going to look like. You guys kind of with me here? Is anybody age 45 by themselves? In this weird thing? No. Right? The minute I start taking groups of people, that's the most likely thing, because that's the average. That's what expected value means. If I do something over and over and over again, the average should come out to be the expected amount. The most likely occurrence. Now watch this. If I do this 31 people at a time, now it's going to be way less likely. It's going to be way more likely to get a mixture. Way less likely I'm just in one group. Right? If I took 31 people and I got nobody from this one, that is very unlikely to happen. Are you guys? I just randomly take 31 people. So what's it going to look like now? It's going to look like this. But what are those? What are those? What is? Sorry, that was really stupid. Each of these dots in this picture represents what?
The average.
Averages. I love it. So this is a distribution of sample means. Shit. Is the distribution of ages by themselves normally distributed? No. But if I plot all of the averages for every group of 31 people possible, I end up with a normal curve. Or normal enough. We put that in a little subtitle. That's kind of cool. So what we need to do, now watch this. Last thing I want to say real quick. Whatever the standard deviation is here, does it stay the same from here to here? Does the standard deviation stay the same? Now think about it. What does standard deviation tell you? Standard deviation, what's standard deviation tell you? Say again?
How many points away from the mean?
Doesn't count the number of points.
It's the distance.
It's the average distance from the mean to every data point. Tells you the spread of the data, if you want to say it really quickly. Right? Does the spread of the data away from the middle stay the same? In this one, are there more data points close to the mean from that one? Stay with me now. Come on. Are there a lot of data points close to the average up here? Nope. Are there a lot of data points close to the average here? Yes. Since they are really close to the average, will the average distance away from that middle decrease? Yes. The sigma is smaller. In fact, to be specific, again, oh, I love you guys. What is this a picture of? Sample means. This is a picture of samples of size 10, their means. So that means, let me put this little sigma x bar. The standard deviation for the sample means gets smaller. And over there, it gets even smaller. They all kind of come to the middle. So if I took one student from here, their grade on the last quiz could be anything, right? But if I took 20 students from here, their average grade is probably going to be close to the actual average, right? Yes? If I went outside right now and just randomly selected one person, they could be any height. Any height they are wouldn't really freak me out too much unless they're really far away from the average. But if I took 20 people, the average height of all those 20 randomly selected people should be close to the actual average. Are you guys with me? Yes, that's what this is saying. The bigger sample size you pick, the closer all your samples should be to the actual average. Is it impossible to get nothing but young people or old people? Not impossible, but really unlikely. That's why it's a really small height there. Oh, scheisse. So, what happened to the mean through this whole process? Didn't change. Please let this make sense. If I take the average age in here one at a time and then add them up, that's a number. If I take 2 people at a time, take their average, and average all those, it's the same stupid number because it's the same people. So the average won't change just because I'm taking groups of 10, groups of 31. But the standard deviation gets smaller. So next time we'll get more specific about exactly how that spread changes, and then we'll see how that affects our work. Oh, shit. This is getting into chapter 7.
You ready for confidence intervals? I don't know.
Oh, no. Help us. All right. Don't forget your IDs and assorted things up here.